In this video, we are going to find the LCM using two different methods. I divide them off into what I call the easy method and the hard method. But honestly, what makes it easy or hard really depends on the numbers that you start with. And you'll see that in a minute. So what I call the easy method is we're simply going to make the list of multiples of each of the numbers. So the list of multiples of 6, well, that means 6 times 1, 6 times 2, 6 times 3, 6 times 4, 6 times 5, 6 times 6, and so forth. And then you make the multiples of the other number, 9 times 1, 9 times 2, 9 times 3, 9 times 4, and so on and so forth. And you make the list until what you find is the lowest common multiple. And if you look, there's several things that are in common. I have the 36 in common. If I went up a little further, I would have the 54 in common. But I want the L, the lowest. So I'm going to find the lowest that they have in common, and that would be my 18. So that's the lowest common multiple. The other one is what I call the hard method, and the only reason I call it hard is because it's got a couple extra steps. But it comes in really handy when we start making these lists out and out and out. I'm finding there's nothing in common. I can't find any list or any number in both lists that match up. So what we're going to do is it's got two steps. The first of all is the prime factorization. Okay, and then after we do the prime factorization, we choose the most of each factor. So let's see what that means. So I'm going to do the same thing for 6 and 9 here. So prime factorization means I take the 6 and I break it down into its prime factor parts. So a set of numbers that will multiply times 6 is 2 and 3. If 2 is prime, which it is, meaning it's the only thing that will go into that is 2 in itself, itself and 1 is there, so that's prime. And 3 is also prime because the only thing that will go into 3 is itself and 1. Then I'm going to take 9. 9 can be broken down into 3 and 3 again, which are both prime numbers. So then what we do is I make a quick list. Well, we had 6 and we had 9. I'm going to make a small chart. And some people are looking at this and go, okay, that's a lot of work when this list over here was super easy. But bear with me because you're going to see sometimes that it gets a little bit nicer to use what I call, again, the hard method. So as I've got this list here, I'm going to take an inventory of everything I see in the bubbles. Well, the only things I see are 2's and 3's. That's the only thing I see between those bubbles. Okay? So then we take an inventory. Well, when it comes to 2's, or excuse me, it comes to 6, I saw in 6 there was a 2 and a 3, so I'm kind of making some tally marks. In 9, there was just a couple of 3's. Now this is the part that really challenges everybody because I didn't say give me the total. For the answer, I want the most. That's the hardest part that most people don't understand. So when I'm looking between each of these, in this column of 2's, there's a 2 here and nothing here. So the most I saw was 1. Now here, there was a 3 in 6 and there was a couple of 3's in 9. And what I want is the most, not all of them. I saw 2 and I saw 1. So the most I saw anywhere was 2 of them. Not the total, the most. And so what I do at the very end is I say this is figure out what this represents. So this one represented a 2 and this one represented a couple of 3's. And if I multiply this together, 2 times 3 is 6 times 3 more is 18, which is exactly what we got over here. So let's look at what it would be if I did it to a couple other numbers. So let's do it for 12 and 15. So the first thing again I'm going to do is the easy method, which is just carrying out the multiples. So 12 times 1, 12 times 2, 12 times 3, 12 times 4, 12 times 5, and 12 times 6. And let's see again, let's do the 15. 15 times 1, times 2, times 3, times, aha. As soon as I find that lowest common multiple, I don't have to keep making the lists. I'm just doing this until I possibly find something. So thankfully I did. Okay, so let's do it on the hard method. So the first thing it said is I'm going to do prime factorization. So I've got the first number is 12. I'm going to break that down into 3 and 4. Incidentally, if you broke it down into 6 and 2, you would end up with the same answer. So 3 is prime, meaning the only thing that will go into that is 3. 4 is not prime because that can be broken down into 2 and 2. So now once it's prime is where I circle and where I stop. The 4 I didn't circle because that wasn't prime. I could still break that down. So let's look at 15. 15 can be broken down into 3 and 5, and both of those are prime. So I'm going to make my chart over here to the side. So I had my 12 and I had my 15, and now I'm going to make my chart here. And when I look at my bubbles, I've got all sorts of numbers. I've got 2s, I've got 3s, and I've got 5s. So I'm going to take my inventory. So when it comes to 12s, I'm looking here. I had a couple of 2s and a 3. When it comes to 15, I had a 3 and a 5. So when I'm looking for my LCM, I'm looking for, again, the most. So I'm going to carry this out. I have a 2 here and nothing here, so the most I saw was 2. I had 1 here and 1 here, and again, I don't want both. I want the most in any one section. So the most I ever saw in any one block here is 1. And then here I want a 5 because there was 1 here and there wasn't anything here. So I write out what that represents. It represents 2 2s, a 3, and a 5. And when I multiply that out, that again is 60. This last one is finding the LCM between 3 numbers. And again, I'm going to start doing it the easy way. So again, I'm going to start making the list. 8 times 1, 8 times 2, 8 times 3, 8 times 4, 8 times 5, so on and so forth. 8 times 7 is 56. Then I've got to do 3 now. So I've got to find the common number between each of them. So I'm looking them out. Now I see the 40s are in common, so I might have something here. So let me look at 12. So I've got 12 times 1, 12 times 2, 12 times 3, 12 times 4, 12 times 5. But if you look, I'm not having anything in common. I know that if I put a 60 here, these two will match up. The 40s match up here, the 48, but I don't have anything in common. So sometimes deciding whether I'm not doing the easy method or whether I'm doing the hard method is simply just exhaustion. I'm carrying out all these lists, and I'm not finding anything. So let's see if I can't go towards the hard method. So I'm going to go towards the hard method, and this might help me out. So I'm going to break down the 8, I'm going to break down the 10, and I'm going to break down the 12, and then line those up. So 8 I can break down into 4 times 2. 2 is prime, 4 is not, so I got to keep going. And both of those are prime. So then I break down 10, which is 5 times 2, and both of those are prime, so I'm done. And then I want to show, earlier in the video I broke down 12 into 3 times 4, but even if I did 6 times 2, I'm going to end up with the same bubbles on the end of the branches. Again, if it's prime, I circle it. If I can break it down, I keep going. So then again, after the prime factorization, I've got my 8, I've got my 10, and I've got my 12, and I'm going to make my whole list here. Let's see what I have in here. I've got 2s. Oh, I see a 3 there. I see a 5. I think that's all the numbers that are in these little bubbles. Again, I don't care that there's a 6 or a 4. Those weren't prime, and I could break them down further, so I don't care. Okay, so let's look at the inventory. So in 8, there's just 3 2s. In 10, there was a 5 and a 2. In 12, there was 2 2s and a 3. So here we go. Again, I want the most. So when I'm looking at this, there's 3, there's 1, there's 2. The most I want is 3. 3 is the biggest grouping. There's a 1 and a 2, that's less than that. Then I want a 3 and I want a 5, the most I see in any row. So then I remember that this counts as 3 2s, a 3, and a 5. And then I multiply that all the way across. So 2 times 2 times 2 is 8, times 3 is 24, times 5 is 120, and that is the LCM. Incidentally, that's exactly what I would have gotten if I carried each of these out continually. They finally would have matched up at 120. So sometimes doing it the hard way actually is easier because you don't have to write these multiples out forever.